Hi guys, hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In my channel, I deal with different subjects ranging from mathematics, physics, chemistry, and biology, and some of the related topics. So today we are going to look at the concept in trigonometry, and this basically is going to be assisting us trying to attach some conditions to some of the trigonometric, or rather some of the geometrical aspects we are going to look at, especially in application areas. Now, the concept of a standard basically has been stretched across the subjects of mathematics and sciences. And as I've said, these are some of the conditions or parameters that we have to attach in order to, in some areas, in order for us to try and quantify some aspects of either mathematics or sciences. So in some cases, we have talked about the concept of standard temperatures, standard pressure. So basically that refers to the concept of standard conditions. And also in the aspect of trying to assign some universal units for measurement, we have talked about the concept of standard units, etc. So the concept of a standard angle or an angle in standard position, therefore, is going to assume that approach in a sense that we're going to look at various aspects of the unity circle that we have mentioned in one way or another in our introduction to trigonometry, and that is going to create a basis for us in trying to interpret this specific concept of an angle in a standard position. So therefore, I'm going to have an illustration on the board, which is going to assist us try to describe this specific aspect of an angle in a standard position. Now, in this specific case, I'm going to use a rectangular coordinate system in two dimensions. So basically, I'm going to have the x and y axis represented as such. In this specific Cartesian coordinate system, of course, I've drawn a right triangle. And a right triangle, in this case, I mean that this specific triangle has got an angle of 90 degrees that is resting on this x-axis given as such. So basically, this is going to assist us elaborate on the concept of an angle in standard position. And previously, we have discussed on the concept of angle measurements, and we said that angle measurements can be done in terms of degrees, or sometimes we're going to measure them in terms of radians. And we have given some of the conversion for this specific stretch for angles, whereby we said we define the concept of a radian as a length which is going to be achieved or made by an arc, whereby this specific arc from the center of the circle is going to form a length s, which is equivalent to the radius of that specific circle. So therefore, this specific angle that is going to be formed in this particular middle is going to be referred to as a radian. So therefore, that is a slight definition of that specific concept of a radian. And we said that we can be able to define a radian by converting the measure in degrees with a multiple of pi over 180. So in that case, for a full stretch over 360 degrees, it's going to be represented by 2 pi radians given as such. So this is going to be given as a small c there. So that is going to imply 2 pi radians. So that is that one having been said and done. In this specific illustration, I'm going to give an angle theta in terms of degrees, and therefore that is what I've indicated. So the stretch between this x-axis and this specific angle is forming an angle theta. And we had said that we're going to refer to this specific extent in the positive direction and the negative direction for a stretch of an angle which is going counterclockwise. So angle measurement in this specific case for the degrees for angles is going to be given as a positive. It is a stretch from this specific x-axis of this terminal side. So this is the terminal, OP is the terminal side. And if I may give this one as point R, then therefore the vector OP is a terminal side, and then the vector OR is going to lie along the x-axis. So I've given it the stretch vector OR as xi and the stretch RP as yi respectively. So these are going to assist us to try to define the various trigonometric ratios that we have mentioned in some of our videos. But in this case, for the point P, I can be able to give its coordinates in terms of the stretch in x and y given as such. So therefore, we can be able to just describe that specific point as a coordinate representing xi and yi, even in that specific order. So in this case, an angle in the standard position is the one that is located in the rectangular coordinate system as I have given, whose vertex is going to rest at the origin of that specific Cartesian coordinate system. So therefore, I'm going to have my O represent the origin. So this angle that is having its vertex resting on this origin and then lying one of the sides xi lying on the x axis and making an angle of theta by a stretch of this terminal side towards the positive side, which is counterclockwise, then therefore it's going to be referred to as an angle in standard position. So therefore, that's how we can be able to define this specific angle. And as I said, this is going to assist us in trying to define various aspects of trigonometry. So apart from defining that specific angle, one of the objectives of this specific discussion was to try and look at some of the characteristics, of course, which we are going to come across in some of our discussion on the application of this angle in standard position. I intend to have this one, so it's going to basically be touching on this point, and this point are given as such. So it's going to, suppose we make a circular path along this stretch given as such, so we're going to have this point given at that specific point. So from the Pythagoras theorem, we are going to have a relationship. From the Pythagoras theorem, we're going to have a relationship that is going to assist us to define the three basic trigonometric functions, whereby we said that we can define the sine over theta given as PR over OP, which is basically going to be given in terms of, so we have PR given as YI, so it's going to be YI over OP, which is going to be RI given as such. So we can be able to define the sine of this specific angle given OP, PR over OP given as such, and then we can be able to define the cosine of this angle theta given as this is XI, so this is going to be XI over RI, and then we can be able to define the tangent or the tan of theta given as YI over XI given as such. So YI over, so the tangent of theta is going to be given by, so we have an acronym, we can be able to use this specific acronym so that we can be able to, so it's going to be the opposite of this, which is YI over the adjacent, which is XI given in that specific respect. So in this case, we're going to see that for various ratios that we have defined for the tan, the cosine, and the sine of theta, for us to define these specific ratios, then we're going to see that the denominator, which is going to be a part of this ratio for Ri for this one, and also for the Xi, these are not going to be equivalent to 0. So we said that a number over 0 is not going to be defined. So therefore, those are going to exist in that specific condition whereby the denominator is not equivalent to 0 as such. So we had said that from Pythagoras theorem, we can be able to give the relationship between these three sides of this right triangle for triangle ORP. So therefore, we can be able to say that for triangle ORP, the relationship is between the sides R and X and Y can be given as the square, the sum of the square of the two sides is equivalent to the sum of this radius over this imaginary circle that I've given in this specific case. So this is going to give us the stretch of R being given as the root of X squared and Y squared given as such. So that is the relationship that is going to exist between these specific three sides of an angle in standard position and its various stretches for X and Y axes respectively. So I hope that this is going to form a basis for us in trying to define various trigonometric ratios. And of course, we're going to see later that basically if you try to have a relationship as well for these three trigonometric functions, we're going to see that we can be able to define the tangent of theta if we divide the sine of theta over the cosine of theta, whereby we have said these ratios are going to be given. So this one can be given as the tan of theta. So these ratios are going to be given as yi over ri divided by the cosine of theta is given as xi all over ri given as such. So therefore, we're going to have this one given as yi over ri times ri all over xi. So ri is going to cancel, and we're going to have a ratio over yi xi, which is basically defining the tangent of theta. So we can be able to define the tangent of theta using the ratios of the sine of theta and the cosine of theta given as such. So catch us in our next video as we're going to look at various applications of, or rather the definition of various trigonometric functions, especially the cosine and the sine of theta in relation to the this specific angle in standard position. And that particular discussion, we're going to look at the concept of a unity circle, which is going to assist us, of course, define those two basic trigonometric functions. So that is it for now, guys. Bye. Catch us in our next video. Kindly check in our description boxes for various links of other videos which are related to this. So that is it for now, guys. Bye.